I'd like to show you in Metron version 8.3 how easy and automatic it is to do the measurements that I think you want to do. So here I'm going into the acquire screen. I don't have a live horse in a live DR system. I'm going to press demo fire to simulate firing an X-ray. So all you do is stand the hoof on the block,
right,
take the X-ray.
front, foot, lateral.
It voice announces the anatomy, which it determined automatically by using neural networks. Now you see it drawing on the image. This is the computer doing it by itself. I'm not touching the keyboard. We've identified the scale marker that's inside the Metron block, and now we're automatically picking key points on the anatomy. I guarantee no other software on the market can do these things. Now when we're finished picking the points, we show various measurements. Here we're showing 4. There's a total up to 10 that we could choose to get. And the ones we're showing here that I think you're interested in, we have the coffin joint angle. That's the angle between the P2 and the P3 bone. If these two blue lines were on top of each other, it'd be 0, but here we have 17 degrees. The pastern joint angle is the angle between the P1 bone and the P2 bone, and that's 4.27. We have a publication posted on aponamine.com under research, where we have a whole paper written just about these two angles, how we measure them, why we measure them this way, what it all means. Now we also have the length of P2, 1.7 inches, and that's the length from the point right here, if you can see my cursor, down to right here. It's pretty much what in a lateral aspect you would think of as the length of P2, but the way it's defined is very carefully, because we try and do things carefully. We fit these two circles, we find the length between the centers of the circles, and then we subtract the radius of the upper circle and add the radius of the lower circle. So if you think about it, that gives you the length of this. You see a red line here with arrows in each end. This is exactly how we define the length of P2. Because if you were just picking 2 points in a radiograph, you might pick from here over to here, or it's not well defined how you do it. To make it well defined, we fit circles, we use the centers of those circles to get us a direction, and then we offset by the radii to get this exact distance here. Now I believe you're interested in the length of P1. That's not one of our standard set of things because so many radiographs are cut off at the fetlock joint that we haven't built that into the standards. But I'll show you how to do that manually with just a few clicks. With one click, we go to the edit page. On the edit page, there's lots of tools, including something called free markup. We go into free markup, and then sticking with our way of doing things here, we'll go ahead and fit a circle to the fetlock joint. And then what we'll do is we'll measure, if you imagine in your head a line connecting this center to this center, we'll stay on that line and pick from here and down to here for the length of P1. And there's our length of P1, and I can change that label to say something nice like length of P1. Okay, so now we're done. We have the length of P1, P2, we have the two joint angles. We could further get a fetlock angle if that's of interest. That would also be done with a few manual clicks. But there you're done. It's all very accurate if the hoof was stood on the center line of the block where our measurement calibration system is. And I would welcome you to show this to any of your colleagues that have told you that Metron can't do this, or to anyone who said that some other software or DR system on the market can do this somehow differently or better. I'd be very curious to get this in front of them and see if they stay with their story.